So these are the things what we see in the last class, right? So this also we've seen. Okay. So now we start with the data analysis of process. So when you say data analysis as a process, what we can call as, which is starting from data structuring, okay, what we can call as defining variable names, types of data, then types of measurement, whether it's a ordinal, nominal, or a scale. Then the next job is what we can data preparation or data management, which includes data cleaning, data preparation, transforming the data. There are so many things has to be done here. Then data analysis, which includes EDA, exploratory data analysis, then diagnostic test, then testing of hypothesis and model testing. Then finally reporting. This is how things are working, right? Okay. So now, even if you see in the previous section what we have shown here, in terms of data preparation, people has to spend at least 60 to 70. So that much of data preparation is required. And when you say model building, only 50 to 20%, right? Okay. I hope you can able to hear me now clearly. Okay. So this is the role of data preparation, data modeling. Okay. Now this can be done with help of R or any other software. So today we'll see more on R-oriented software to do this, and we'll slightly test the JASP also. Okay, as you know that whatever you are doing in JASP without code, with code you can do it in R. And please understand, JASP is internally R is working. It is not something different software. They put a wrapper, that is what they call as JASP. So these all things we are or why JASP. Okay. So let me take first why R, then I'll introduce why JASP also. So R is a, okay, and it is an open source. Okay, more than 25,000 technique can be used. For instance, when I say domain-wise, if you are a part of marketing guy, there may be research. If you are part of financial guy, you may have 100 packages meant for time series or cards model, arts model, ARIMA, and regression. There are so many things are there. And what are the report we are generating? In R, it is very much customizable report. Unlike other proprietary software, you can create your own packages and algorithm also. And it is R is very much compatible with other open source like Python and Julia, H2O. Okay, if you are working in H2O, you can use R command internally. It will work. Same thing, if you are working inside R, you can write the Python command also. In that way, it is compatible with each other. Not only with the open source, even with the commercial software also. When you say commercial software, software like SPSS, you can take the code of R, inside SPSS, you can write the code of the R. So in that way, these all are very powerful, we can say. Okay. Now, the research reproducibility. When you say research reproducibility, when you're working in the team, the research reproducibility very important. So assume that a team has got 10 members, and out of 10 members, you have 3 different processes happening. Okay, so first 3 members trying to develop a program, they're trying to develop algorithm, and it is, and this algorithm can be used by other 3 people, and they can have a cross-checking the same output or different output. In that way, you can say research reproducibility is very much feasible with help of R. And R support for a great community support. Okay, when you say great community support, which includes if you have any doubt, you can immediately clarify with help of R community. How to access R community means there is something called R bloggers is there. You can just go to Google, you can subscribe our bloggers. So every day they will send some 5 to 6 tips on how to do that also. Okay. Now, for instance, I'll show how the R blogger looks like for you. Okay. Let me show how our bloggers come to you, right? Okay. Can you able to see this, my email now? Can you able to see the email now?
Yes, sir.
Hello.
Sir,
Okay, so
yes,
you
sir.
can see this email. Now let me go to, I'll just click on the top. I'll take our bloggers, right? The moment I type our bloggers, okay, you can see day wise every day, right? Can you see that bloggers? Starting from, I'm giving May 8, May 9, 10, 11, every day I'm getting bloggers. Okay, so through this blogger, I can able to understand how to report it, how to use a script. You can see how to understand the word embedding in arithmetic, YR. There are every day, even today also we got again around 4:18 a.m. in the early morning we get things. Okay, so this is the advantage of what we can call as using our blogger. So I request everyone to use these R bloggers for your benefit. So this is a great support come from R. We don't need to pay any money for this. And apart from that, there is R Studio, because what we are using is R Studio rather than R. So R Studio conduct many webinars. You can register and you can, at cost of free, they will educate us how to use R in a server level, in a deployment level, in many level. So in that way, these programs are quite, subscribing these bloggers are quite useful to us. And it is really, it is give a lot of understanding about the different process in R. So in that way, we suggest, okay, R is really good, because if you go for SPSS or go for SaaS, you have to purchase their product. Then only they will send their flyers or whatever bloggers. But in terms of R, it is not like that. Okay. Now, before using R, there is some cautions. The caution number one is, in R, commands are very case sensitive. Okay, we can't just type just like that. Better to use always a lower class rather than upper class. And most of the R output looks cluttered, stored in the form of a list. List is one type of data structure. Okay, but we can redesign this output or structure of the output by using a various packages in R. For instance, if you want to do a regression reporting, use a TextReg packages, that is what I mentioned here, which can provide you much better output than a normal R output. Okay, one concern with R is, unlike SPSS or other software, remembering R code is not easy. First of all, you no need to remember at all, because you can't by heart 100 lines or 200 lines. Only thing is, we need a constant practice makes a person to use R comfortably. Okay, initial learnings look like a bit of a struggle, but over the period, we can see the learning curve is very, very high, and especially it being very steepening, and your understanding towards the statistics completely change when you use a R compared to other software. Okay, then R has got multiple packages, so we should decide whether we have to use package A or package B. For example, here we have considered okay, to import or export a file from Excel to R or vice versa. We have multiple packages. The first package name is what we can call as Open XLS. The another package is what we can call as XLS packages. But which package we have to use, that should be decided by a researcher or analyst like you. Whichever is more reliable to use, you can take it, or whichever the industry follows, you can follow the same thing. And at last, we have one concern is, R never give any warranty for the product. If something goes wrong, we cannot go and claim compensation to R, because it's a open source, right? So this all the typical what we can call as a caution to use R, right? Now let me take a same thing. Okay, if I just want to take, okay, now why JASP? Okay, in the same place I'm going to ask why JASP. First of all, JASP is a, okay, when you say JASP, okay, JASP is a statistical, it is not a program and it is not a language, it is a package. Okay, it is a package, right? Packages supported by R. So completely it is our people who develop all these things. Okay, it come from Amsterdam University people. And one thing is, yes, it's open source, and it does not have more packages like R, but it's including basic analysis like testing of hypothesis. When you say basic analysis, basics, which includes your testing of hypothesis, right? Okay, then apart from that, you can use all regression, most steps of regression, PCA, cluster, and machine learning. So that's one of the greatest advantage of using JASP. And there is no domain-wise statistical tool. They're most of the time they're focusing on questionnaire-based data, and what we can call as machine learning. Few machine learning, not a complete machine learning package, but few machine learning algorithms are available, right? So that is one reason. And reports are okay. It is not customizable report, but reports are very standard report. The reports are very standard. Standard report. They're following typically APA format. They're following the what we can call as APA style. So when you say APA style, it's American Psychological Association style. They're following for citing the tables and the graphs and diagrams. And there is no question of you can create your own function because it's a package, right? So that is not feasible at all. So let us remove this. Okay, and research reproducibility is very much. Okay, when you say research reproducibility means whenever you do any work, okay, if you want to see what is the process, what is the output, and if you're sending to your people or your team members, they once they open a JASP file, they can also parallelly see how it look like. So in that way, okay, JASP is research reproducibility is very very high. Okay, and yeah, anyhow, it is come from R, so statistical rigor is very very high. There is no doubt at all. So this all the purpose of using, and for you, why I'm using parallel, why I'm using a JASP, because JASP known for we can call no coding, right? No coding concept. Okay, mean to say normally we will say no pain, no gain, but here we can say it is like okay, no, okay, there is no pain, but gain is there. Okay, that is why we are using a JASP. Okay, not only people say no pain, no gain, but you can say there is no pain, but still there is a gain is there by using a JASP. That is the reason why we are looking for JASP as an alternative tool. Okay, so what I'll do now, so we are crossing 30 minutes of our time. First 30 minutes, or I can say 40 minutes, I'll show things in or to change it to, so because I'm repeating the same portion for two section. To break the monotonous, what I'll do, first I'll take a 15 to 20 minutes time on JASP. Then I'll show same thing in a R also. Okay. I hope that's clear for you. It is okay for you. It's okay for you. Okay. So what I'll do now, okay, the best thing is I have to log the. Okay, fine. So I believe this is clear for you. Okay, I'll start with the JASP just to avoid this monotonous from my side. Okay, so let me share the JASP to you. Okay, I have to open a JASP. Okay, can you able to see JASP file? Everyone can able to see the JASP file? Can you able to see the JASP file? Yes. Okay, fine. Okay, okay, thanks. Okay. So here, when you see the JASP file, this is a file. Okay, let me say how to import the file first. You can just go here, open recent file. When you say recent file from your computer or something called OSF, okay, for that you should register, or data library, right? Okay, so let me go to your computer. Let me go to my computer, then browse it. Okay, so I have to go to let me say others. Okay, from the folder called business analytics. Okay, you can see I'm choosing a card CSV file and open. Okay, can you see this file now? Can everyone able to see the file?
Yes, sir.
Okay, so this is how I imported. It's very straightforward how to import the file from CSV to JASP, right? So now, okay, let us take this. If you see the topmost view, we have descriptive. In that, we have descriptive statistics, t-test, ANOVA, regression, frequency, right? Then factor analysis, machine learning. So we'll only bother about this all the tab for the future classes. Okay, and why I've chosen JAS, one reason is machine learning, because if you do machine learning in R, you need more number of code, more number of understanding, but here in one click, you'll get everything. That is the reason, as per the guidelines of your director, he asked me to take a Rattle R, but Rattle R is even much, this JASP is much sophisticated than a Rattle R, so I use JASP here. Okay, now just to quickly take the descriptive statistics. Now you can see here, okay, now I want to find out how many cards are there. If you just go to the class, you know what is class? No? The class means a card segment, whether it's a compact or a mini or a mid-size. So I want to know how many cards are available. So how to do that? Let me go to descriptives and descriptive statistics. Okay. Now you can see here data here. Let me take class, drop it here. Okay. So once I drop it, nothing going to happen here. But you can see there's something called frequency table. Can you see here? Frequency table is nominal and ordinal data. So you can use only nominal data. Click this.
Sir, we're not able to see your screen.
So now you can start in a fraction of a second. You got so many things. One is this two-seater, compact, mid-size, all the things. Oh, not able to see your screen.
Excuse me, sir.
Then you said
No, sir.
Yes, no, sir. We are not able to see.
Is it okay now?
No, sir.
Can
We
you
are
able
not
to
able
see the screen?
So we are in the previous
No.
screen.
What
The
about now?
previous screen is showing, sir.
You can't.
Where you
Which one?
computer, sir? From computer.
Computer tab is selected, sir.
Okay. 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 Oh, okay, okay. Till that screen is there. Okay. Let me show once again. Let me share it. Can you able to see this screen now?
Yes, sir. Yes, sir. Yes, sir.
Hello. Hello.
Yes,
Can you
sir.
able to see the screen now?
Yes, sir. Yes, sir.
Okay. Now let me read from the beginning. Can you able to see this data now? Okay. Some disconnection. Can you able to see the, everyone can able to see the screen?
Yes, sir.
Hello. Can you able to see the screen?
Yes, sir. We can able to see, sir.
Yes.
Okay. Okay. So now what I'll do, I will go to descriptives. Okay. Here descriptive and select the variable. Okay. This is what the things comes, right? So what I'm trying to do is variable, drop it here. So it will show like this, right? Okay. Nothing showing. you can see this frequency tables. Just click this frequency table. Now you can see it is producing what all things is producing. One is a frequency count. So out of 234 sample, these are the count of observation, then percentage, then valid percentage, then cumulative percentage, right? So that is what it shows. Now, the moment you are trying to see these things here, okay, now how do you interpret this table? One advantage with a particular thing, what you can call as software is, let me try with some plot also. If the plot is there or not. No, this plot is not meant for this one. Okay, let me take distribution plot. Okay, this is how the plot shows, class wise. Okay. So now, how to interpret this table? Very interesting point is I can edit the table. Right click, add note. So in the note, what you can say, you can add it n equal to 234. That is called sample size. Out of this, you can say which is the highest one. You can see 20, the percentage. 26% goes to what we can call as goes to SUV. You can say SUV occupied 26%, okay, followed by what all things are followed by. So SV occupies 25%. We can say followed by what? Followed by 20% called compact, or you can say compact and subcompact comes under compact only. So 20 plus 14, it is almost 34-35%. You can say compact and subcompact together contributed for 35% of the sales, right? That is how we can do that. Okay. The least contribution, you can say least contribution is come from one is two-seater, right? Two-seater, which is 2%, and minivan come from 4%, and minivan is 4%. That's all. So this is how you can do this. Now, if you want to copy paste things to your model or to the things, you can see here. Can you able to see this? I'm copying this. Right click. I made right click. Copy this. Right. Now go to your any Word document. Okay. If you just go to any Word document, then let me open the Word document. Okay, so let me go to any Word document. I just open one Word document. I'll paste it here, right? So I'll go and so now you can see that what, can you able to see the screen? Hello, everyone, can you able to see the Word document?
Yes, sir.
Hello? I don't know whether they...
Yes, sir.
Yes, okay, fine.
Yes.
See, this is what I did it in JASP. Can you see this? So job look very simple here. Okay, so whatever I did it, I copy pasted, my job is done. And I got interpretation here itself, right? I made interpretation. This is made in JASP. I can copy paste also. In this way, I can say, okay, JASP is like a kind of a very user-friendly software. Is it clear? Okay, now going back to JASP again. So this is what is one meaning called descriptive statistics, right? Now going back to JASP again. Okay. So now the next job here is, I'll go back to dataset. You can see dataset just like kind of slider. Click here, you'll come to dataset. If you want to get the output, click here, you'll get it. If you want to complete output, click here. So it will take a complete output. It's a kind of sliders. You can see the slider. You know what is slider, right? So if you click here, you will get the data output with a process. If you click here, you will get the data set. So this is a kind of slider. First slide is a data set. Second slide is a process and output. And third slide is only output. If on click this, then you will get whatever you want. Now, if you see this is a categorical variable, I got this. Okay. Now, if I want to find out one simple concept, what is the concept here is, I want to find the concept is okay in the year wise. If you take a year, where is a year here? So year shows a there are. Let me check how many years are there. How do you go? Just go here. Okay, in the same data, what you'll do now, you add a year also. So you will get a separate what we can call as a table for year. Can you see here? So here is equally 117. Okay, equally 2 year. 99 and 2008 only. And if I want to find out, okay, 99, which all the cars are highly introduced. In 2008, which all the cars are introduced. So if I want to do that, very simple logic here is what I'll do. Okay, if I don't want to disturb this output, okay, at the same time, I want to take a new output, class versus year. The simple logic here is go here. Can you see something called plus? Can you see this? Click the plus. Okay, so you will get again it is repetition. I'm going to do my cross tabulation. So I can change this. I can edit this. Edit the title as cross tabulation. Cross tabs between what? I can say class by year. Now, what is the thing? How the output will change here? Take the year from here, drop it in the split. Got it? So now you can see that complete report is coming this way. Like what you can call as 99 and 2008. Okay, how the things are there, whether you want this or other way also. Okay. Now, if you want to take a add any node, you can add it also. Okay, and you can see the graph also generated in a two different year wise and year two. So you can see more or less same pattern. Year wise also same pattern. Year two also same pattern. Right. So this is one of the advantage of using this software, what we can call as JASP. Now, if you want to copy paste, you can copy paste same thing in the Word document and you can do. If you want to make any edit, you can do edit, and if you want to make any note, you can make note also. So now the next job here, let me go back to the data set. Okay, now what is the next job I have to do here is, okay, we want to find out this is nothing but city highway, miles per gallon. What is the miles per gallon in the city wise and highway wise? So if I want to know what is the means for this descriptive statistic, into the okay descriptive statistics, then say you can see city, you can take it here. Then you got the output here. Now just click off second, you got a mean, standard deviation, minimum and maximum. Same thing you can do for highway also. Okay, while comparing the two things, how do you compare the two things? Okay, take the mean of city miles per gallon. Okay, it is look like a 16.85 miles per things. What about highway? Highway is 23. So it seems to be that the same car running in a highway give better miles 23. We are getting 7 miles per gallon is much better than your city. That is what we are trying to understand through this, right? Okay, and standard deviation is 5.4.2 and 5.9. How to interpret the standard deviation here? Okay, now let me say that if I want to give a notes for this, so add a notes. So what we are trying to say that, okay, on average, what we are trying to say on average, okay, when cars, okay, used in city roads, okay, MPG is miles per gallon is 16.85, right? And in highways, miles per gallon is 23.4. So it seems on average, a car is efficient in highways while compared to city roads, right? Because we know that city you put so much of traffic and you have to apply the brakes frequently, changing the gear and holding the accelerator. So this all will reduce the efficiency of mileage, right? That is a reason for that. Now further, if you want to say, okay, what is the standard deviation? Okay, ESD, you can say ESD. Okay. Okay, now let me take M. When you say M equal to means always it is M stand for mean. Okay, right? M stand for always mean. SG stand for standard deviation. So SG for okay on what we can call as a city, SG equal to you can say this figure. The figure is what we can call as 4.2, and highways SG equal to 5.9, or you can say it is a close to 6, right? So how to interpret this? So we know how to interpret the average, how to interpret the standard deviation. Any idea how to interpret the standard deviation? Anyone can throw your idea about the standard deviation?
So, from top of my head, standard deviation is nothing but what it says that how much deviation is happening from the standard set.
What
So
is standard set here?
here the standard set is
Hello?
yes, sir.
Yeah, what is the standard set you mean to say?
So, for example, the standard is say 20, and here,
No. See here, what is the standard means? It is a 16. Your mean is a standard, right?
okay.
So from the mean, what is the distance you are taking? That is what we can call as 4.25, one standard deviation. For a highways, from the mean 23.4, what is the distance you are taking? 5.95, right? But what is the meaning of the standard deviation? So when you say standard deviation, let me type it so everyone can able to understand. Okay, standard deviation indicates what you can call as consistency. Okay, lower the SD, higher the consistency, right? And higher the SD, lower the consistency. Is it clear? That is what we can call as standard deviation implication.
So we can also see this from variability point of view, right? Or
Yeah, that
inconsistency point of view.
see, that is what we call as consistency, right? Variability or consistency. So now compare two things. Which is more consistent? Which vehicle is more consistent? Which vehicle used in city or vehicle used in highways? If you see the cities, which seems to be very consistent by referring the standard deviation.
Vehicle used in cities.
Cities, because its standard deviation is 4.2, right? So
Yes, sir.
okay. Statistically, okay, statistics confirm or results confirm that what we can call as okay, cars in the city roads seems to be more consistent. Seems to be more.
Shankar sir,
Yes,
sorry
ma'am.
to disturb you, sir. Sir,
Uh,
actually, many students got disconnected due to this network problem, sir. Can you please
okay,
unlock the meeting, sir?
unlock.
Yes, sir.
Okay.
Due to
I'll,
problem network issue, sir, they were not able to join.
I got it. I got it. I got it. Okay. Okay, I unlocked it.
Okay,
Thanks.
thank you, sir.
Okay. So rest of the people who are here, okay, I hope you are following what we are trying to convey. Okay, so this is what we are doing, right? Now we got output, we got interpretation. Now, how do we paste it here? Right click and say copy. Okay. Now go to the Word document. Okay, let me share in the Word document. Okay, so this is first output what we got. Now second output. How the second output comes? Paste this. So now this is second output. Can you see this? So this clearly shows that descriptive statistics on average. If you want to keep this table thing, what you can do now, copy paste this table before the things. Okay, now you can say, if you want, just change only one line is from the above table, right? That's all. That's enough. From the above table. Okay. Then we are explaining what is this on average. When cars used in city road, MPG is M equal to this, and it seems so and so average this. Okay. Then okay, on city SD, in city SD this is much, highway is this much, and it's consistent, right? So that's how the output comes, and the output looks very neat also. You no need to bother, right? Is it clear? Any doubt in this? I think this is very clear for you, right? Now the next job is for me. I'll go to my what we can call as, I'll go to again JAS. Okay, so we got these things. Now, so there is a question there. Okay, we know city and highway overall. These are overall score. Please understand. These are overall. If someone asks, can you do same thing for class wise? In a class wise, what is the city's mileage, and for highway also? So as I said, don't disturb this output. What you can do, just plus it. When you say plus it, you'll get a new output. Same output with a thing. So you can go and edit the title. So edit says that what I can say, descriptive statistics by class wise, right? That's all. By class wise or segmentation wise. So take your class variable and drop it in the split. So now you can see that you are getting output in a such a way that, okay, you are getting a count, a proper count, missing value, mean, standard deviation, minimum and maximum, right? And all this class variable. This is for what we can call as a one, right? So we are getting everything. You can see it look like a city wise. Okay, if you want, like let us, if you want, instead of giving such a big table, if you want to break it, what I suggest, just keep only one city wise, right? Then again duplicate it. So when you duplicate it here, this time remove the city and keep the highways. So now you can see this, okay, this is a descriptive statistic, this is the descriptive. Only the difference here is, if you want to make this, if you want to show this is edit title, you can say here, this is highway, right? Highway, and this is city. So this will give a very clear-cut understanding on okay, how the output look like. So you can see comparably, okay, in every sector, you can see that, okay, 2 seeker years 15, year 24, a big difference. 15, 24 is almost like a 10. Year 20, year 28, 18. So in everywhere, both the cards are entirely different. Means to say that the miles per gallon is very, very high in highways, going by the city also. Okay, so we can use some sort of test. Can you say that this test 15 minus 24 or this, is it statistically significant or not? Please understand, sample come from same the sense, out of 234 cards, what are the cards? Here also you can say same number, 5, 47, 41, 5, 47, 41. So both are same car. So we are taking a car and we are running in a city, and same car we are running in a highways, and we are trying to calculate what is the miles per gallon in highways and what is the miles per gallon in city. And after computing, we are trying to figure out whether the difference is same or different. Okay. Now, if you want to find out whether difference is same or different, okay, we can use a simple technique. Okay, first let us see the difference. How is the difference is happening? So how do you compute the difference here? There is something called, we need a compute variable, new variable. So let me go here. You can see this is a plus sign, right? Click a plus sign, and we are creating new variable called difference. Difference in what? MPG, right? Between a city, and create a column. So you can see this is what we created. Now computation should happen. How do you compute here? You can see these are the variable names, and these are our function names, right? Okay. Now, if you just go here, the variable names, Let me go to variable names here. This two thing I have to minus, city minus this I have to minus, right? So take a city, so take a city and say a highway, right? That's all. You can see what I did. I just selected city and clicked here and put a minus, and again I just clicked here and say, you can see compute column, right? Now we got it. You can see that, okay, how I'm calculation is that if you see here from the city, okay, then city is 18, highway is 29, minus 18 minus 29 we got 11. So like that for every person we made a computation, right? So now if I take this, what is the difference? Average difference also. So what I'll do now, so let me go back to the data set, right? Let me go back to this output. So here what we'll do now, we can duplicate this one also, right? So we'll duplicate, remove the city from here. Instead of that, we can take difference. Okay. So you can see the average difference between these two things is 9 miles per gallon for a two-wheeler. Then for a compact 8, 8, 6, 3, 7, 4. So by and large, there is a big difference between all these people. Okay. So for instance, if you take mean of here 13, the mean here is 18. So that difference, what we can call as what we can call as here as 4.6. That is how the difference is computed. Now question is, can you say this difference is statistically significant or not? Okay, very simple logic is go to your t-test. There is something called paired sample t-test. What is called paired sample t-test means the sample come from the same source, like before and after, or two different situations. Here sample, all the 234 cars come from the same owners. The only situation is a owner is driving in the city, owner is driving in the highways. That make a difference. Is it a significant difference or not? For that, we can use a paired sample t-test. So click a paired sample t-test. Now select the variable. I have to select the variable city and highway, right? The moment you choose a thing, okay, and if you want to click here, you can click descriptives, right? And descriptives plot. Okay. So let me say what is going to happen here. So what is a graph indicating? The people who are using cars in city, their average miles per gallon is cheap, right? If the same car owners using the same car in the highways, it is close to 24. And this difference we are establishing, okay, with the help of this technique, right? If someone asks what is the difference in this, okay, what we can do here, okay, so the mean difference, what's the difference here? 6.58. So on average, out of these 234 car owners, when they're driving the car in city and highways, the average difference here is 6.58 miles per gallon. That is what it is. Is it significant? How we know that? We can check this. Can you see this? P-value is less than 0.001. Yes, it is significant. So we are proving that yes, a car running on highways will be much efficient in terms of fuel compared to car running in the what we can call as in the city. So this is what is the implication of the studies. Okay. If you want to see the effect sizes there or not, then you can go by Kogan's D. Normally we don't bother about all these things, but this is a basic analysis we have to bother, right? So what we did as of now in JASP, okay, let me take what we did in JASP all this time, okay. Now, okay, here also, okay, let me take a interpretation for this. If you want, I'll make interpretation here also. So let me add note. What does a note says means, on average, okay, city-wise mean equal to, you can see the figure is 16.8, right? So 16.8 and highway. Highway wise, M equal to, M stand for mean, equal to 23.4, right? And difference, significant difference is, we know what's the difference you can take from here. The significant difference is 6.5, and it is okay. Okay, what you can say, the p value also. Where is a p value less than 0.01, right? So p value 0.01. It is statistically significant, right? That's it. So that is how we have to interpret, right? Beyond this, we don't want any interpretation on this thing. Okay, now if I want to export all the output in a single shot, okay, what we can do here, okay, just go here. You can see copy, right? You can copy all, copy to clipboard. So once you did that, we can come for any kind of what we can call as Word document, then we can paste it here. So it is asking some granting some permission, because the graph is that last permission. For table it not ask. Okay, now you can see all the result has come in a neat format. Okay, then further we can just change whatever you want. You can see now. So result has come, okay, with interpretation what we did earlier. So you can see by default it is Times New Roman, right? By default Times New Roman. So it is working here in a neat way. Okay, graphs may not be look so nice, but since this program, this package is in a beta version, they may improve in a future also. Okay. So this is how the tables and analysis look step by step, and what we did like a t-test also, pair sample t-test. So this all are there, right? And you can straight away can submit your work also. This is how it is come, right? So now any doubt in this? Any doubt in this, or if you say it's very clear, then I'll go for R. Any doubt on this? Everything is clear? Any doubt? Yeah, any doubt? Otherwise, shall I go for forward? If you have no doubt, I can go for next level.
Yes, sir.
Yes,
Yes, sir.
okay,
Yes, sir.
okay. Okay, thanks. Let us go for next level. Okay. So now we have saw with the JASP. Now we have to go to now something called R. Yes. So you should understand why I'm using JASP, because going back to the PPT what I showed, right? That is called in the PPT. Okay, the purpose of JASP is no coding. This word is very important. No coding, no pain, but there is a gain. So that is why I used JASP for you to make understand. Especially, I'll revisit JASP when I'm taking a parallel session with R also. Okay, now I'll go to R now, right? Okay, so this is where we stopped in R. So now in R, everything is object. Okay, last class we started with R, right? Any doubt in, can you able to hear me? In the last class we started with R, right? I introduce what is object. Am I right? Yes,
Yes,
or
sir.
no?
Yes, sir.
So what I'll do straight away, then I'll go to R. Okay. No need to bother about this. I'll straight away go to R. Can you able to see the R screen now? R studio screen. Can you able to see the screen?
Yes, sir.
Yes, sir.
Okay, fine. That is good. Okay, now the first job in R is we should know where is our system is existing, the drive of the system. The next thing is, okay, we have to say that, okay, how to change the directory. Okay, to understand where the directory is located in the system, get WD control enter. So you can see this is my directory. So I am in user, Apple, desktop, others, business analytics, and BA. So that is my uh, root directory. Okay. Now in that I kept a file name called cars. Okay. So cars is a file. Whatever the file I shown in a JAX, same file I kept it in a CSV file. So how to import the CSV file? There is a .csv and cars. So read.csv is a function. So any function in R, for example, take read.csv. The moment you click the parenthesis, so if you see the normal parenthesis, you should understand this is a function. Are you getting the point? That's a function. Okay. So I have to run this command. So in this read.csv, we are saying that cars.csv, control enter, right? So the moment you say control enter, okay, so that file got come inside, the file is imported to R. So how we know the file is imported to R or not? Okay, now let me go here. I'll say view cars, right? If I say control enter, now you can see this is a file comes to R now, right? The whole file what we have shared with the JAS, same file comes inside the R also. Is it clear now? Okay. That is how to know whether file come inside the R or not. So you can just close this. Fine. So once we did that, okay, if I want to know the variable names, there are some function to call as a basic commands in R. Okay. What are these basic commands in R? Because you don't know what is the file, what file contains, what type of data, how many variables, how many cases. Okay. So in each variable, what are different types of data that we don't know at all. Just to access that, to understand that, we have some basic commands. The basic commands starting from names. When you say names, it's very simple that names of file. Names in the names of the variables in the given file. Okay. So here, what is the file name? The file name here is what? Cars. So enter. So it shows this all the variables available in the variable names in the file. Is it clear? Okay. Okay. Now let us take a head command. What the head command can do for us? The head command we can do, it can just say display first 6 rows of data. That is what we can call as head command, right? So once I control enter, it will get it like this. Are you getting the logic? Okay, that is how the head commands comes to you, right? So now you can say something called a tail command that will like display the last 6 rows. So you can say here 1 to 6, the last means 230, 229 to 234. So this is what we can call as last 6, right? So head meant for displaying the first 6 rows and tail meant for displaying last 6 rows. If you want to know the data type, whether it is integer, numeric, factor, character, just say structure cars. So structure is a function, car is a file name. Control enter. So this is what is the file we call. You can see the structure is 234 observation, 11 variables. Okay. Then you can see manufacturer as a factor, model as a factor, Then you can say display is a numeric, integer, factor, and factor. Please understand when you say factor, for the face value, it look like a character, but internally it is storing as a numeric value. That is what we can call as factor. Now, if I want to convert this factor into character, how do you do that? So very simple logic here is, if you go here, okay. Now first I should check whether a particular variable is a what kind of data. It is a factor or something. Okay. Now what I'll do here, okay. Let me take this one. Okay. If I'm going to, let me take this example for you. Okay. So first I should know whether it's a character or factor. What I'll do, there's a function called is dot factor. Is dot factor for the data cards variable name called manufacturer. So we know here, anyway we know here, just to check it, I'm just giving the code. So answer will be only two, whether it's true or false. It says true. Now I want to convert this into character. How do you convert the character? There's a command called as character of cards manufacturer and storing again in the cards manufacturer. Please understand this attachment. What do you mean by attachment? Means when you say car is a file. In that lot of variable is it. But if I want to choose particular variable, put a dollar sign. That is called cards dollar sign. You can see attachment, right? That is called a dollar sign is attachment. So I can pick whichever variable I want. So let me take manufacturer. Clear? So cards dollar manufacturer equal to as dot character of car manufacturer. So now this changed your variable as a character. How do I know that? Let me run once again here. Now it shows false. Earlier it shows true, now it shows false. Means it has become now character. Is dot character. Now it will show true. Can you see this? So this is how to change a particular variable from character to factor or factor to character. That is how it has come, right? Fine. So I hope you are able to understand a few functions what we have seen in R. Let me go back. First, I showed how to import the file, right? And second thing is how to view the file. And third thing is basic commands to understand the file, to understand the variables, to understand the numbers behind the variable. So we used names, head, tail, structure, then dim. Dim stands for dimension of the cards. So what is the dimension here? How many rows, how many columns? So we have 234 rows and 11 columns. That is what we can call as dimension of the variable, right? Then summary. What do you mean by summary here? So when you say summary, control enter. Okay. So you can see the summary. Okay. For any continuous variable, you will get a data like this, like a minimum, maximum, mean, median, standard deviation. Only thing is we won't get a what we can call as a standard deviation. We will get remaining things like mean, maximum, mean, median, more, then first quartile, second quartile. This all we can get except standard deviation. So that is how the summary comes to picture. But if you want to get a standard deviation, you can get it also in a different way. Okay. So this is all the basics what we did here. Now to get a standard deviation, to get a more statistical form, we can use a package name called psych package. So how to install a package? Very simple here. There is a command called install.packages. Okay. Then we have to say psych command, right? Psych is the package name. And just type install.package inside the bracket psych and control enter. The moment you enter control enter, it will start downloading the package from our URL, our web pages. Once you did that, you can just put a non-executable command. Then library.psych to invoke the package. So the package got invoked. How you know package got invoked or not? So type the package name psych and double click of 2:. The moment you put 2:, you will have so many, you can see functions and so many data set. Okay, whichever comes like a Excel format, this all data set, and remaining things are function. So this is all part of your psych packages. Okay, by default you won't get psych packages in R. We have to download the packages and we have to keep it. So how to download the packages? For that, we have to make install.packages. To invoke the packages, we have to say library of psych. So in this, there is a one command called what we can call as describe command. Now we'll see what is this describe command in R by using psych package, right? Okay, so if I run this command called only describe command, let me copy this and do it here. Describe chords. So now you can see what describe commands implication for this. So describe command shows, see all kind of output. This is similar like your JASP output. Actually, JASP getting output from here only. So this including standard deviation also you can see. We got standard deviation also. But in this output, you can see mean, standard deviation, minimum, maximum, everything is there. But one thing is tricky point here is you can see in the variable name, everywhere you are getting some kind of manufacturer, some asterisk, model asterisk, okay, then trans asterisk. So what is the meaning of that? Whenever asterisk comes, the given data is a factor or character. So it does not make any meaning for us to input in the analysis. So we can drop that analysis. How to drop it? I'll explain how to drop that. But we should first note down the numbers which we require without asterisk. One is displacement 3. Okay, that is a key number. Then city 8. Then highway is 9. So 3, 8, 9 is key number for us, right? So how do you get the uh, required data? Instead of taking the whole data, how should I filter it? How should I keep or drop variables? So for that, we'll see very simple logic here. Okay. So now this is my data set cars. One, you can see now the bracket is changing. All the time I'm using only this ordinary bracket. Now I'm using square bracket. Can you see this? So square bracket indicates what? Data subsetting. Data subsetting. When you say subsetting, I can take only the required rows or I can take only required columns. I don't want to take whole data. Okay, now what is the meaning of this? For instance, if I'm saying here, okay, in this bracket, square bracket, you can see there is a comma. Anything before comma, that's indicating rows. Anything after comma indicating the columns. That is what's a simple logic here. So if I run this command 1:3, 1:3 means take first 3 rows, take first 3 columns. That is a meaning. Can you see this? So whole data set, the whole data set, how it look like? We know that whole data set, how it look like. For example, when you run the view command, let me run once again. So this is your whole data set. But what I'm trying to do here, if you see here, first 3 of rows and column. So first 3 means this 3, and you can say only this 3, right? So anyway, it is choosing everything. What I'm saying, I'm taking manufacturer, model, and this proportionate, and this 3. So this is what we are taking, right? That is how the output has come here. Is it clear? Now let us check if I want to data set larger data set. I mean to say, instead of saying let me take 5, then 5. So now you can see it's increasing 5:5. So that is the purpose of the square bracket. It can indicating which are the variables you have to take, which are the variables you have to drop, right? So now the another logic for this, if I want to choose a particular variable rather than continuously seriously like this 1 from 5, so I want to select only 157 rows. Okay, now let me remove this. And I want to select 389 columns because we know 389 columns is what we require. So for that, we have to use a function called C. You can see here, okay, I'm taking only first 157 rows, column 389, and we have to use a function called C to collect a different elements. That is the meaning of this. So the moment I run this, control enter, now you can see the row is 157. It doesn't take 2, 3 or 4, 6. It takes 157. In terms of column, it has taken only third and 8 and 9. So if you just go and see the data set here. So what's the third column? This is the third column. Okay, and 8, 9. So 8, 9 comes here, right? So city and highway. That is how it has come. So I hope you can be able to understand it, right? Okay, so go back to the R command. That is the purpose of this. Okay, now if I don't want this 389, but I want remaining thing like 1, 2, 4, 4, 5, 6, 7. Then simple logic is I just put minus in front of this. Control enter. So now what it shows that okay, okay, I should done for this one. Okay, now you can see that 157 and it takes except 389, it takes other variables. So that is how this is working, right? The result is when I say the result, okay, when I say the previous command, describe command contains all this output. I'm storing this command in the object called result, and result also got all this output. But in this output, in the row wise, what I want here is only 3, 8, 9. In the column wise, what I want is mean, standard deviation, minimum, and maximum. So if I count the numbers from the left to right, 1, 2, 3, 4. So mean is third position, standard deviation is fourth position, and minimum maximum is 8 and 9. So in that way, what we are doing is result is equal to, we are saying that, okay, take 3, 8, 9, mean to say, 3 stand for displacement, and city and highway, and in terms of column we have to choose only mean, standard deviation, minimum, maximum. That is called 3489. Just run this. Now you can see your output becomes so small now, right? So we got a nice output. We no need to take such a huge output now. So that is how the output has come, right? Just a minute. Okay, can you able to see the screen now? Okay, so this is what we did as a first level job. Any doubt in this? So whatever we have done. Any doubt in this? Is it clear?
Yes, sir.
Okay, now what I'll do now, quickly I will do one more technique. Okay, if you, okay, because I'll come back to the remaining part like a table, what frequency, how to do it in R. But as a quick things, what I can do here is, okay, to just run the paired sample t-test. You remember what is a paired sample t-test? So you can say same thing, t-test. Okay, you can see this pairwise t-test. Okay. So in the pairwise t-test, what I'll do here, okay, let me read the whole thing, what is pairwise t-test does. Otherwise, the easy way is, if you got stuck in how to do that, go to help. In the help, you can type, okay, you can see where is pairwise t-test. Okay, so this is how help will look like now. So what it shows here, you can see, okay, what is a pairwise t-test? And if you want some example also, they'll give some example. For example, here, pairwise t-test, okay, they're taking for from ozone and month. Okay. Okay, this is how I'll do, right? Like what I'll do, let me try now. Pairwise t-test. So cars, dollar, city, comma, cars, dollar, highway. Oh, this is something different actually. What I'll do now, okay, we'll go with t-test itself. Okay, so if you see this, what is a t-test formula. Right? So there is something called paired equal to false. That's all. Remaining thing is as usual. Okay. So what I'll do here, p dot t test. Okay. What you have to call CTY till HYW. The next thing is what you have to say, paired equal to true, comma, uh, data equal to us. Okay. City not found. Otherwise, okay, first there is one other way of doing help is type example, okay. Then in the bracket you can type p dot t test. So this will give a lot of different examples for us. For example, if you take it here, okay, how to use a t test? It shows okay t test of what we can call as, this is one way of doing t test. Okay, then so you can see this is what we tried now for a simple t test. Now other t test is what this say here is, okay, you can see that t test come from here also. Okay, whether this will work or not. Let me try this. So t test, what we can call as odds dollar city, then y equal to odds dollar highway, comma, add equal to true, right? Yeah, yeah, we are getting now. Okay, so you can see the output here. This output may not look very user friendly because of this how the R output will go. So if you see this is nothing but paired sample details. Please understand this is a paired sample. This is a paired sample details. Paired sample t-test, right? So if you see this output here, paired sample t-test, what we are doing, this is one city figure, this is a highway figure, and we are comparing the paired sample t stand for true, and this is the output what we are getting here. So if you see this output, okay, you'll get the same mean score. If you see the mean difference, how much I'm getting is 6.58. The same mean difference what we got it in your JASP also. For instance, if I go back to JASP, okay. Okay, if you just go, this is a JASP, you can see paired sample t-test. You can see what is the mean difference here. Same thing. Can you see this? 6.581. And this is a mean. You can see t value. What's the t value? 44.4 something, right? In the R also, you'll get the same output. Okay, you'll get the same output in the R also. Okay. Let me go to R. In the R also, we are getting same output. You can see T value is 44.429 and degrees of freedom is this, and this is less than 0.001 and mean value same. So in terms of output, both are same. The only difference here is what we are trying to do it here. Okay, this comes very cluttered way, that comes very neat way, but you can make this also neat way. For example, here, let me take library broom. So we put a library broom. Then we have to paste this output in one thing. Let me say pad t test. That's the output name, right? So once you put a library broom, that will mean for getting a good output in terms of reporting. Now there is something called tidy, then pad test. So now you can see same output how we getting here. So this output looks so cluttered, but the moment I used a broom package and tidy function, the same output comes like this. You can see there's nothing but difference 6.58. This is your t value. That is called t value. This is your degrees of freedom. Okay, and what we can call this is a lower limit, upper limit. Okay, and this is your p value, right? Less than 0.00. So in both way, you will get the same output. Okay, but using broom package and tidy function, your output looks much neat actually compared to normal R output. Okay, this is why we are saying that okay, the R output is cluttered by default. For instance, there is a one place we said, okay, if you see that, remember this, okay, R looks, the output in R looks cluttered in the list form. But however, good reporting can be ensured through variety of codes and various supporting package from the R. So that is what we are trying to do that here also. Though we are getting a kind of output like this cluttered output in R, this cluttered output we revised by using a library called Broom and package called library or package called Broom, function called tidy. So once you do that, you will get the neat output like this. This is one option. Other option is you can directly go to JASP, okay, in a one click, because you can see this, how much time you are spending to writing a code for each one. And since I have been in this field, I know what is a package, what is a function, how to type it, what to get, what not to get. Even something goes wrong, I can able to turn around quickly. But novice people like you may not do all these things. It will take a lot of time. So the alternative, what I suggested is what we can call as JASP. So you can see the same output comes in JASP, which much better full way. So if you want, you can give the same graph also, or you can give some kind of relevant graphs like this, much better for us. So this is what I want to cover for today's session. Any doubt as of now? Okay, please welcome on this. So I invite people has got doubt, please clarify it now. Otherwise, we have next session on a coming Thursday. So I hope you should practice every day. There is no other shortcut for this. And one more thing is, okay, any doubt, please shoot a mail to me in this. This is my email ID. Okay, shoot a mail to this. If you have any doubt in JASP or R or fundamentally on research and statistics, please shoot a mail. Then that will benefit you in a very large way. Is it clear? Is it clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. So if there is no doubt, I can wind up the session, or I can wait for another 5 to 10 minutes. If you have doubt, I'm glad to clarify that. You have no doubt. Then let me end the meeting now. Shall I close the session? Hello. Hello. Can you able to hear me?
Yes, sir.
Okay. So shall we close the session then?
Yes, sir.
Okay. Thanks, Clinton.
Yes, sir.
Yeah. See you.
What is the problem? Sir got disconnected.
Session finished, ma'am.
तो मीटिंग क्यों नहीं खत्म? आई थिंक ही इज नॉट एंडेड.
सर लेफ्ट द मीटिंग, हमको अभी छोड़ना है बस.